So the last one of these artifacts, objects, communication technologies, whatever you want to call them, that we're going to look at is assessment. And the kind of counterpoint here in traditional assessment is this image here, which is a bit of a meme, which has gone around on the web. It's students doing an exam in Thailand, a university in Thailand, apparently, and it's a kind of a metaphor for individual thinking, no sharing, memorizing stuff, coming into a room, and it's this very strange process. At the end of a course, you got a defined period of time when you're going to just say what you remember or get things right on the basis of some sort of procedural knowledge. So this is, if you like, the classical model. And then we create e-tests, e-assessments, and guess what? Nothing changes. It's the same logic, the same process. What I'm going to do very briefly is just mention the standard model. We actually have another series of videos where we go into assessment in much more detail, but I just want to mention it briefly here, which is, that what we have in the standard model is select response assessments, which is A, B, C, D answers. And what we have as an alternative is what's called supply responses, which is you go in and you write an essay, more or less. And these are very, very strange objects. Again, we sort of speak about this in more detail in our other video. They depend on long-term memory. And long-term memory, the definition of long-term memory is it's until the day after the exam. It means that you've got a very narrow cognitive range of things that you can actually be assessing in A, B, C, D supply response, select response assessments, which is, can you get it right? Which is, can you apply a formula correctly and get the right answer? Can you remember something? Also false positives, where, on the one hand, you might get the wrong answer, but really know how to think it through, but just made a mistake. On the other hand, you happen to get the right answer by just by accident. They're very strange artifacts, which is, where in life do you do these kinds of things? It's not, most of learning doesn't involve these kinds of things. You just do it at the end. And it's also very limited sampling. It's a 3-hour exam at the end of a semester, let's say, or whatever. And also what it does is that, they're nervous making. You felt bad on that day. There's something you remembered afterwards that you should have said. They're not always happy experiences. They're also kind of linear, which is you do the course, then you do the test, which is a kind of regards education as a linear process. They're isolating and individualized when in fact knowledge is social. They're retrospective and judgmental, which is, the kind of logic is, in retrospect, what did you do? And we're going to judge you, and it's called a B+, which means you're a mediocre person. You're not too bad, but you're not too good either. But the most important point that we want to make is that they insist on inequality, right? In other words, in order to have a distribution across a curve, they're insisting on inequality. So when we go and do these tests, this is the standard model mechanized. So, those kids in the room with their blinkers, this is mechanizing it, and it's called, machine-based, item-based testing. Now, what we're still doing is this classical model of insisting on inequality. So this is actually, if you want to know literally the technicalities of IQ tests, and this is where the bell curve originated, that this is, the IQ idea and the mathematics of IQ was invented by Henry Goddard in the 1920s. And in fact, those days, there were technical terms for people who got between 0 and 25, idiots, and 26 and 50 were imbeciles. Morons were a bit better than that. Did you know the difference between these words? Well, they've become words of abuse now, but we still use the positive words a fair bit, above average, gifted, and we like to think there are some geniuses in the world as well. But what happens is the kids come into a class and we want to do this distribution to them. No matter, and look, the irony is that what we've already done is we've already graded the kids by age, graded them by admission into some fancy program, and even though we've tried to make them as similar as we possibly can, we then want to make them unequal by doing this distribution when we come in. Now, what we want to argue, and what we've been doing with Scholar, is try to build an alternative model which is based on the old notions of mastery learning that Benjamin Bloom and his colleagues were working on 50 years ago now. So what we have is we have this thing called an Astor plot, and we're looking at a whole range of different things, different types of activity, which there might be classroom discussions going on, there might be peer-reviewed projects going on, there might be surveys, which are item-based tests going on. So there's a whole variety of assessment mechanisms, some of which are quite traditional actually, like rubric-based reviews traditional, item-based assessments traditional. And what we've done is we've divided those into 3 macro sectors, which is a knowledge sector, a focus sector, which is sometimes called grit or perseverance, how much work you've done, how much effort you've put in. But we also have added a help sector, which is the extent to which you have been collaborative with other people, how much collaboration you've done, you know, have the other people rated your reviews highly because they found them helpful. So we have a whole lot of measures. Now, the outside circumference of this circle is a data point that's, or an aggregated data point, which has been determined by the instructor as the set of objectives, okay? The width of each petal is the weighting of each of these various measures. In fact, we could change the sector weights. We could change the weighting of knowledge in relation to help, in relation to focus, but we can change the width of each petal in a quite granular kind of way as well. Now, when you start, the theta, which is the old psychometric concept, in the middle is 0, and you can see the Astor plot becoming more colourful and reaching those objectives over a period of time. You mouse over any one of these, and you see a little mouse over like that, and you click on the mouse over, and there is a text which explains exactly how that data is being calculated. And here is the place where this is the admin area where the teacher, the instructor, the professor, whoever it is, the instructional designer for that matter, sets the objectives for a particular unit of work. And by the way, they can change these objectives and supplement these objectives on the fly because what's happening is the work the students are doing is being continually data mined. So this here is, I'm the instructor, and this is the theta for the whole class. This happens to be the 79 students in that class of Mary's and mine about assessment that you saw before. Earlier in this set of videos, and you can see here that there have been 9,000 odd pieces of small, what we call semantically legible feedback. These are small, actionable pieces of feedback from the machine, from peers, from instructors, self-analysis. So in fact, what we've been doing is giving a lot of formative assessment along the way across nearly 2 million data points. So one of our arguments is this is the potential for learning analytics in the future to be data mining a whole lot of activity. And our kind of radical proposition is we can end the distinction between assessment and instruction because there's no instruction without formative assessment, and there's no need for separate assessment because assessment is embedded everywhere.
Bill and I have been working for decades in classrooms of all types, in primary school, in high school, at colleges, in universities, around the issues to do with literacy, pedagogy, multiliteracies, learning by design. But in all those years and in all the work that we did, we realised that the strong grip that high-stakes testing or traditional testing had on pedagogy, on curriculum, on the ecology of the classroom, on the experience of the classroom. And we realised that without tackling assessment and transforming assessment into something that was directly associated with learning rather than an afterthought, there was no way in which those aspirations that we all have for learners could be achieved. So part of the motivation behind the design in Common Ground Scholar, in CG Scholar, in the making of this particular ecology was in order to allow for the evaluation process and the assessment process to be happening as students and learners were performing, as instructors were engaging with them. Because this environment, one of the affordances, of course, of the digital environment is that it can collect what we call data or information or traces of all sorts of behaviours, social behaviours, artefact production. And by collecting them in targeted and specific ways, we could form a profile of a learner's performance and a learner's progress that meant we could finally tackle the high stakes end of process tests, which have put a stranglehold on the living and learning that occurs in classrooms. So this is our attempt, and we'll describe the kind of the more recent tool that we've developed. And I want to emphasize again how you can change the pedals on the Astor plot depending, on the repertoire that suits your goals or the learner's goals or the instructor's goals. But for us, it was important to say that knowledge is not the only thing that's important in any learning experience, but the degree to which a learner engages, wants to engage, is motivated to engage, that aspect of the learning matters and needs to be captured. If it matters, it needs to be captured and fed back to the learner. And of course, collaborating, we know, is the highest order of performance, sharing information, building knowledge together, creates permanent or more permanent understandings of subject areas. So it wasn't an accident that we put these three components to the Astor plot. As I said, they can be adjusted, but he was trying to lead us towards those aspirations that we've always had about the learning experience, that it has to be human, that it has to be social, that it has to involve progress and engagement, that it needs all the participants in that learning experience to have the same set of values and respect and dignity in that process. And we can't get to that without addressing that thing that we call testing and assessment. So we hope what we've shown you so far demonstrates the way in which our pedagogical aspirations and the design of learning ecologies are related.